The first of our functional groups in the hydrocarbons are our alkanes. They are probably our easiest. So the exercises to look at and the further reading is pages 135 to 138 in our SciPad, particularly pages 136, 7 and 8. So alkanes have got the functional group of a carbon-carbon single bond. So basically it's the absence of a functional group. They have a general formula which you can apply if you know how many carbons you have. You can work out how many hydrogens you've got automatically. So the formula is CnH2n plus 2. What does that mean? Well, it means if I've got 2 carbons, so my N would be 2. 2 times 2 is 4, plus 2 is 6. Sure enough, 1, 2, 3, 4, 5, 6. Let's say we had 7 carbons, so heptane. 2 times 7 is 14, plus 2 is 16, so it would have 16 hydrogens. A general formula can be really useful for doing this very quick calculation to work out what's called the molecular formula. So, the other thing we need to know about alkanes are their different types of formulae, so that we can understand isomerism and that sort of thing, which we will do in year 13. So there are 2 types of structural formula. A structural formula shows how the atoms are laid out in 2-dimensional space. In reality, it's in 3-dimensional space, and we could use Lewis diagrams for that, leading to their 3D ball and stick diagrams. But for this, for organic chemistry, we're going to use structural formulae. Now, there is another type of structural formula, which was alluded to in the video, the TED talk that was put up. However, we're going to ignore that one for now. That's a way that we'd use to represent our organic chemicals at tertiary level, so at university. The 2 we need to know are our expanded and our condensed structural formula. They show that functional group still. So here is every atom and every bond, so it's a bit like a Lewis structure. This one here is that one condensed. So we can see each carbon has got 3 hydrogens around it. So we can condense that as CH3, CH3. I keep my single bond between the carbons there though. And the reason I do that is to show the bonding, to show this functional group. It is just a single bond. Once I have my structural formula, I can condense that even more to make the molecular formula. How many carbons, how many hydrogens, and this links back to our general formula. So if we know our general formula, we can actually work out this, and then we can rearrange these atoms in space to try to make it one of these 2 here. And of course, once we've got this, we know it's 2 carbons, it's a single bond only, 2 is eth, and single bonds is ane. We can get its name ethane. Now, I'm just going to move my camera down a bit to show you this other one. This is a bit of an extra for experts, okay? So you can switch off now if this isn't for you. Cyclic alkanes also exist. And what we have to be aware of there is that they have a different general formula. If we look here, there are 5 carbons. So this would be what we call cyclopentane. Cyclo for the cyclic bit, 1, 2, 3, 4, 5. Cyclopentane, but it's only got 2, 4, 6, 8, 10 hydrogens. So it would be C5H10, not C5H12, which pentane would be. So its general formula is a little bit different. And that's worth noting because the general formula for what we call straight-chained and branched chain, so not cyclics, is CnH2n plus 2. This will become important later when we look at polymers because we need to remember that nothing's been added to them when we try to work out the structure of our monomer. Then we don't get confused and suddenly add more hydrogens in.